I made a video about a Boolean proof of a Boolean identity, but I didn't talk about in general the Boolean identities, the fundamental principles or the laws. So I will do that in this one. So if we look at an OR gate, this is like that. OR gate is like 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 1. Well, an AND gate is 0, 0 gives 0, 0, 1 gives 0, 1, 0 gives 0, and then 1, 1 gives 1. So basically OR means we're looking for ones. So if this one A is 1 or B is 1, then we are getting output as 1. That's the meaning of OR gate. But for AND gate, it's similarly the AND as we understand normally. If both are 1, if A and B are 1, only then the output is 1. That's how we can interpret these gates. Now there's some Boolean identities like this one. Let's say A plus 1. That means A or 1. So since this is already 1, the output will be 1. A can be 0 or 1 because a Boolean can have only two conditions, 0 or 1. So or A or 1 is a 1 anyway. A or 0 will be an A, because if this is 1, A is 1, then output will be 1. If output is 0, then output will be, if A is 0, output will be 0. Looking at the AND option, A and 1 is always A. It's like algebraic product. If we see, it's the same, but even conceptually, if A is 0, 0 and 1 is 0, or if A is 1, 1 and 1 is 1. So whatever is A is going there. Similarly, if this is A, this is like algebra also, it's 0. But the reason is, if A is 0, whatever A is actually, basically, if A is 1 or 0, since it is being ANDed with 0, both has to be 1 for the output to be 1. Since 1 is already 0, the output will be 0. Then looking something else, all these laws have different names, but let's not go into the names, because if we just understand them conceptually, we can just remember them to be able to use them appropriately while using solving a Boolean problem or even afterwards. So yeah, A or A bar, that means if A is 0, the other one is 1. If A is 1, A bar is 0. So this is always 1. And then A plus A is always A. So A or A, if both are 0, then output is 0. If both are 1, output is 1. This one, A and A bar, will always be 0, because whatever A is, one of them will be 0. If A is 0, then it's already 0, and if A is 1, the A bar will be 0. So the product is 0. And if we do this one, this one is again, if both are 0, the output is 0. If both are 1, output is 1. So basically this is a, basically it won't be a square. That's the thing. There is a very important Boolean identity which I proved in the other one, in the other video, the only video I made on Boolean algebra. So this is the one. Please, for proof, look at that one. But this is an important identity which we can use when we are solving a Boolean problem. So basically these are the most important ones. There are few more, probably I will just have a, so this is a little bit, look at this one. This one we don't need to remember. What we can do is this 1 plus b. So we get the, since 1 plus b is a 1, as we saw, because 1 is it's an OR option, OR option and one is one of them is 1, so the output is always a dot 1, a and 1, so output is a. That's how it is. So basically I will just talk about this for the time being, but this Boolean identity mostly comes from understanding, and we don't need to remember all the laws. And De Morgan theorem I already talked about, but I will just quickly finish that off as well here. So this one goes like that. So this is a NOR gate is becoming like an AND gate with the inverters, and this one becomes like that. So basically whatever it is, if it is an OR, it becomes an AND. If it is an AND, it becomes an OR, and if bar is on whole of it, then it will become on each of it, and if it is yeah, it's just the other way around. So yeah, that's how it is.